Now let's give more functionality in car class. So set mpg, set guess is there. So let's read guess. So get guess const. So const function means by calling this function, none of the member variables, instance member variables are changed, then we call it as a const function. The benefit of using that or declaring const is a compiler take advantage of that information and then it may produce more optimized code. And then let's do get odometer, also const function. So get guess, get odometer, double car class, get guess, const function, return guess, int get odometer, const function, return odometer is there. So here let's do some testing. Is that we want to do some automated test-driven development. So is that for each code we want to confirm that. So after setting the guess, we can assert that the C1 get guess should be 10 gallons. And the assert function is in C assert library. So when this condition is not met, the program just quits, giving some information, and then you can debug the code. So assert function is not actual deployment purpose, but for the development purpose. As you develop the code, make sure that this assertion succeeds, then correct implementation is tested and the like. And then one thing, so let me anyway compile the program and then let's run it. And then nothing happens, but assertion fails. Suppose I checked with 11, which is error though, but what you can see is that assertion failed this part at line 8 of a main function. So you can examine this code, and this test code error. It has to be 10 instead of 11 and the like. So that is a assert function. And then what we have added is get odometer and the get guess as well. So in main function, we can check the initial condition, assert that C1 dot get guess is initially 0, and then get odometer should be initially 0 and the like. Then as I compile the program, it runs okay. However, when you check equality with the equal sign, you have to be very careful if those numbers are not integer. But if it's a double or a float number, the equal may not work correctly. So that's a very important concept. The reason is that there is a truncation error in a programming language if you deal with a floating or a real number like one's a double or a float and so on. So let me show you that part. So when you set guess, and let's add 0.01, 0.01, 0.01. Let's add 5 times 0.01, 0.01. So that's a 0.05. So 0.05. So let's assert that because that is a 10.05. So let's compile the program and then let's run it. What it says is that the assertion failed. So at this moment, get guess is not equal to 10.05, but this is a 10.05. Then the error might be implementation of set guess function. In set guess function, I don't see any logic error at all, but however, assertion failed. So what's happening? Let's use the debugger to see what's happening. So start. There, C1 is this guy. So let's unfold the value mpg guess and there. So step over, step over, step over. Now set guess, we add 10.05, but what you get within guess variable is a 10.049999, not exactly 10.05, so we have a assertion fail. Why do we have such weird number instead of 10.5 is the number representation in programming language like C++ is that when you declare double, which is intended to be real number, like in math, real number has infinite numbers. Like even between 0 and 1, you have a unlimited number of numbers there. But in a computer, there is a finite numbers. So double is actually 8 bytes in size, which is 64 bits. So using 64 bits, mathematically, you can represent up to 2 to the 64th power. So this is how many real number like double numbers or floating point numbers you can have in C++. But in real math, you have infinite of those ones. So when you have a double type, the representation is not continuous, all of those ones. It's discrete numbers are represented. So close to 0, you have many is there. As you have a bigger and bigger number, then the next number is some gap there. So those numbers are not represented. So whenever a floating point or a double number is represented, you write something like that. Then if this is mathematically somewhere here, but in a double type can represent only this one and next one is this one, then this number is approximated to the closer ones. So that's called the truncation error in floating point numbers in programming languages. So when you compare directly with the equal sign, if it's not an integer, you need to consider those truncation errors. So that's one of the important issue when you write the code. So how do we take care of that truncation error is as follows. So unless it's integer, like odometer is integer type, so you can directly compare. If it's not an integer, never ever use a direct comparison. Let me stop the debugger. So this is not the one you should do. Then what you do is take the difference, and difference is small enough, then consider it as 0. So what I mean by that is double difference, compute the difference, C1 dot get guess, and then 10.05, take the difference. If difference is small enough, depending on which one is bigger, you may have a negative. So let's take the absolute magnitude only. That is FABS function is available in C++ library. So that is on CMath library. So in CMath library has a FABS function. That is this value is computed. If it's negative, then corresponding positive value is returned. If this is positive, the value itself is returned. So take the difference of the two. Then when you assert C difference is small enough. So difference is smaller than 0, something like this. Then consider it as equality. So what is a good number of the small enough difference is depending on your application. In a guess, in real life, this small difference, we can ignore that. If this is a money value, for example, then fraction of pennies, if difference is like 0.001 penny, then you can consider those two are the equal value. So depending on your application, you can determine how small is small enough to ignore and consider as equality. So that's the sum strategy. So to make a little bit more professional code, then in your application code, you can define like a const double e. Small enough value means 0.00001, or depending on application, define that and then assert against the small enough number you have defined. And putting them together, we can do something like this. Assert FABS, the absolute is less than E. Something like this. That's a professionally looking code for checking equality of two floating point numbers.